Hello and welcome to another How to Code Well tutorial. My name is Peter Fisher, a freelance web and mobile applications developer. Today we're going to be focusing on the Linux Bash shell. We're going to be focusing on a very beginner-friendly area of the Bash shell, and that is changing directories, navigating ourselves through the Linux file system. Now I'm running an iMac here, and that has a terminal which supports the Bash shell. So these commands that I'm doing today can be used in other Bash shell environments such as Ubuntu or any kind of Debian-based Linux distribution. Now there are different types of shells. I should mention that there are Z shells and CH shells and different variants of a shell that you can use. So let's just dive in and start working our way through the Linux commands. Okay, so I have the shell here, which is just this terminal window. It looks pretty boring at the moment. It's just black and white, so black background, white text. You can always change this in the profile settings. So at the moment we are in the home directory. The home directory is the home of my current user, which is Peter Fisher. If I was to type pwd, which is print working directory, we can see the full path of that directory. So if I did pwd and then press enter, then that is the full path from users and then Peter Fisher. So if you were running perhaps a Debian or a Ubuntu or a Linux Mint distribution, then you would probably get /home and then / the name of your user. So the first slash is the root directory, and we can do that. We can go into that by pressing CD. CD, it means changing directory. So CD and then /. So that's going to change the working directory from this directory, which is users Peter Fisher, into the root directory. And if we did that, we can see that we have now changed. If you notice, we've changed from tilde to a /. Now a tilde means that you are in the home directory, and we'll talk about that in a minute, but / means that you are in the root directory. And in order to list the directory out, you would use the command ls. So that's listing the structure. Notice that so far these commands have been quite easy to remember. So pwd, print working directory, cd, change directory, ls, list structure. So if I did an ls and then press enter, we can see that we have this list of directories and files that we have here. Now you're not going to get all of these directories. You're certainly not going to get Mac OS _SDK. That's something for a mobile application development that I've been doing. You also won't get this file here, which is the installer.failure request. This is something that I installed before and it failed, so I've just got a log here. You certainly won't get the swarm volumes. This is something I've been working on for Docker, and you won't get the other bits and pieces that are Mac specific. So for example, library, if you were running a Linux distribution. What you will get, however, are the var, the etc, possibly the dev and the tmp and other bits and pieces. Now we're going to talk about what those mean, what those folders mean specifically in future tutorials. Today though, I'm just going to show you how to navigate yourself through a folder structure. Now what we're going to do is just change the working directory back into the users directory, into my home directory. Now again, if you're on a Linux machine, this would be something like /home and then / your username. On a Mac, it's /users and then / the username. But there is a way that we can do this both together, and that is by using the tilde, which I mentioned before, which is this tilde here, this symbol like that. So what we need to do is type cd, because that's changing the directory, and then we put in the tilde symbol. Now this symbol is on the lower left hand side of your keyboard if you're using a Mac keyboard, by the shift key. So we press shift and then tilde and then /. And what that's doing is saying change the working directory to the home directory of the current user. So let's press enter, and there we go. We've gone straight back into the user's directory. Next, we're going to be creating a directory. So what I'm going to do is make a directory, and we do that using the mkdir command. So that's make dir or mkdir. So we're making that directory, and that's going to be a completely empty directory. What we need to do is put in a space, and we're going to offer a directory name. So let's do test for now, and then press enter, and that's going to create the test directory. Of course, we can change our working directory to go into that new directory that we've created. And of course, to do that, we would do cd, and then you would type test. But the bash shell comes with its own autocomplete feature, which means that we don't have to type all the commands out in full. So we've typed cd already to change the directory. And if we just did TES, for instance, and then press tab, it will know that we want to change to the test directory. It knows that there's a test directory there because there is no other file or directory beginning with the word TES. Let's just remove that a little bit and just go back to TE. Now press tab and you'll get some more info. You might have to press it a couple of times, and you can see here that we have a couple of bits and pieces that you probably won't have. The terminal setup.git, which is my way of setting up my terminal profile and so forth, which I'll talk about later on. I've also got some other bits and pieces, including this test directory here. So test and then /, and you can tell that it is a directory because we have a slash there. Whereas this test.json, test.txt are obviously just files. So let's just do TES and then tab again, and we've got test. So let's cd into that. And if we did pwd, we can see that that is the full path that we've got. So we're in our users, then Peter Fisher and test. And as I've mentioned before, your folder structure might be quite different depending on the distribution of Linux or depending on your general setup of your system. Now I'm going to be doing more tutorials on Linux, and we're going to be looking at more commands and more options in the future. The commands that I've showed you today have options that we can provide that change the behavior of those commands. More about that later on. If you have found this video helpful, then do show your appreciation, give it a thumbs up, do like it, and do give me some feedback, put some comments in, and so forth. Thanks ever so much for watching. Happy coding, everyone, and I will see you again in the next tutorial. Cheers. Bye. Hello and welcome to another How to Code Well Linux tutorial. The last tutorial I showed you how to navigate around the terminal, around your bash shell. Today we're going to be taking that a little bit step further. Today we're going to be building directories in a different way to how we were doing it last time. Last time I just showed you how to create a simple test directory. Today I'm going to show you how to build a bunch of directories with no time whatsoever. We're just going to build this very quickly, and it's only in a single command. Now we're in the home directory here, but let's go into the directory that we created in the previous tutorial, and that was cd into test. So that's going to move into the test directory. If we typed ls, we can see that it's completely blank and completely empty. There is nothing in here. Let's say, for example, you need to create a whole bunch of nested directories within this test directory. So these directories are going to be within each other. Now you might think that you just need to create those directories individually. Well, there is a way we can do this in one single command, and that is using the mkdir command that we used in the previous tutorial, but supplying an option to create parent directories if those directories do not exist. First of all, let's demonstrate what other options are available and how to actually get those options. Now, to get the information about the usage of the mk directory command, we supply another command before we supply the mkdir command. That is info. Now, this doesn't happen on all commands that you want to find information about. Sometimes the usage can be found in different ways, and we'll be talking about that later on in future episodes, future tutorials. But for now, let's just type info and then mkdir. Now this is going to supply the information about this mk directory. So let's just press enter, and here we can see some information, some descriptions, as well as some of the options that are available for this command. And if we were to press spacebar, we can move down a page. So for example, if I press spacebar here, we can go down a page like that. And if we can navigate up as well to go up and down if we want to go down a single line or up a single line. So here we can see that we have 3 options available. The first one is -m, which is mode. The second one is -p, which creates intermediate directories if required, which is what we want to use. And the third one here is -v, which is verbose when creating directories. Let's just focus on the -p for now. This creates intermediate directories as required. If this option is not supplied, then the full path prefix of the operand must already exist. On the other hand, with this option specified, no error will be reported if a directory is given and the operand already exists, which means that you can create lots of nested directories and not necessarily worry if a directory in the middle already exists. I'll show you what that means in a minute. Intermediate directories are created with the permission bits of 0777. I'm going to be talking about file permission in far more depth in future videos, so don't worry too much about that. And then it goes on to say, as modified by the current umask plus write and search permissions for the owner. Again, don't worry too much about owners and groups and globals and write access and read access and all of that. Don't worry about that too much today. I'll be focusing on that in more depth later on. That's quite a big topic, and we'll be certainly delving into that a lot deeper later on. Now, to come out of this, press Control C, and that will go back into where you were before in the terminal here. And what we can do is now do mkdir -p. Now, what this is going to do is it's going to create intermediate directories if they don't exist. So let's do foo /bar /1 /2. Okay, so let's press enter, and what we've gone and done is we've created that directory structure. Before this tutorial, you probably would have created directories one after the other. So you've probably created a directory, then changed into that directory, and then created another directory, and so forth and so forth. This command allows you to do all of that in one simple command. Not only that, is it will create the directories if they don't exist. If they do exist, you won't get an error. Let's see those directories. Let's do an ls, and we can see that the first one is foo. So let's go and see what's in this directory. Let's type ls foo, and you can just put in a couple of characters, then press tab because of the autocomplete, which I mentioned in the previous tutorial. You can now see that we have that directory structure. If I press enter, then the next one is bar. So what you can do is press up on the keyboard to get the previous command out of the history. And again, I'm going to be talking about the history in far more depth later on. So we do ls foo. If you press tab, you can see that you have bar, and if you press tab again, you have 1, and press tab again, you have 2. Let's press enter, and you have nothing in that directory. But that's a very quick way of creating those directories if they don't exist. If they do exist, you will not get an error. So let's press up a couple of times to move into that. So we now have mkdir -p, the command that we used before. We've essentially just pulled this out of the history by pressing up on the keyboard. Let's do / again, and let's do 3. So we're going to create a third directory in this structure. So let's press enter. So we didn't actually get an error, even though those directories were already created. Let's just test that out. Let's do an ls into F, and then press tab, and then press tab again, and tab again, tab again, tab again, and there we go. We've listed the structure within number 3. If we pressed up to take that out of the history again, removed 2, and then pressed ls, then we can see that we have a directory of 3. Okay, so that is a very quick way of creating directories. Now, I'm going to be following this up with several other Linux tutorials. If you like the series so far, do give me a thumbs up. Do put your thoughts in the comment section below. Thanks ever so much for watching. Happy coding, everyone, and I will see you again in the next tutorial. Cheers. Bye. Hello and welcome to another How to Code Well Linux Bash Shell tutorial. Today we're going to be focusing on removing directories. In the previous tutorial I showed you how to create nested directories using the -p to create intermediate directories if they don't exist. Today we're going to be showing you how to remove those directories. So the first thing I'm going to do is just go into the terminal here. And then we're just going to change the directory into the test directory that we've created, because right now I'm in my home directory. So let's do a cd into test. Right, now let's press ls to list that directory that we have as foo. And if we did ls of f and then press tab, again we can go all the way through and we can see all the directories that we've created. If I was to go back to 2 and then press enter, we can see that we have 3. Likewise, if I went up to 1, we have 2, and then back down to bar, we have 1, back down to foo, and we have bar. Fine. So that is our nested structure. So in order to remove a directory, we can use the rmdir command. Rm means remove, dir is directory, so remove a directory. You have to be very cautious on this because there are some ways that you can get this wrong and that will screw up your system. I'm not going to show you how to do that in this tutorial. I'm going to be showing you how to screw up your system in another tutorial. I'm not ready for that just yet. So let's remove these directories. Now I'm going to show you 2 ways to do this. The first is to remove the directories one at a time, and the second way is to remove all of them at once. And that's the thing you have to be cautious on. Okay, so let's remove number 3. Number 3 was the last directory in this structure. So we're going to use the rmdir command. If you just type rm and then press tab a couple of times, you can see all the other commands that are available to you. We want this one here, the rmdir. So just type in d and then press tab again, and there you go. So we're going to remove a directory here, and if we just typed in f and then press tab, tab again, and again, and again, and again, we're going to remove the last directory in this chain. So we're not going to remove the whole thing. We are literally going to remove number 3, directory 3. So let's press enter, and there we go. Notice, however, we do not have any output. There is nothing saying it's been removed. There is no safety net here. So I'm going to show you how to do this with a little bit of a notification, if you will. But first of all, let's go and check that that directory has actually been removed. Let's type in ls and then f tab bar tab 1 and then another tab 2, and if we tabbed again, it will not show number 3 because we have removed that directory. So that's removing a single directory. I'm going to do that again just to show you how to remove number 2. So normally what you could do is just press the backspace to remove this from here, but let's just press Control-C. That brings another line, another prompt, and it cancels out the previous prompt. Let's now do rmdir again, and this time if we do foo or f and then tab again, number 2, and then pressed enter, that's going to remove number 2. Again, if we did an ls of f tab bar tab 1, and then there we go. So we've removed that too. Now, one thing to remember here is that the rmdir command will only remove the directory if the directory is empty. And I can demonstrate what happens if you try and remove a directory that isn't empty in this example, because we have the foo directory, which has the bar directory, and so forth and so forth. Let's just do rmdir and then just type in foo. Okay, so that's going to remove foo. If we press enter, we have the rmdir foo directory not empty, and that is because it has a directory within it. So what we need to do is remove these directories recursively. So what we're going to use is a different command. This command is just rm, not rmdir. Rmdir will only remove a directory if it is not empty, hence this error that we have here. So the other command that we're going to use is rm. So just type in rm for now. And that command is extremely powerful. I want you to be very cautious when you use this because you can wipe out other bits and pieces if you're not careful. I'm going to just show you the usage of this just so you have an idea of what the other kind of arguments and options that you can supply to this command. Type in info or man if you need to for manual, and then space and then rm. Now this is going to bring up the information for that command, and again we can use the up and down keys to go up and down lines, or spaces and page up and page down, and so forth. Okay, so a lot of these arguments here we're not going to be using apart from the -r. -r, which is equivalent to capital R here, will attempt to remove the file hierarchy rooted in each file argument. The R option implies the D option. If the I option is supplied, the user is prompted for confirmation before each directory contents are processed. So the -D option, if I scroll up to the top, will attempt to remove directories as well as other types of files. So it will act a little bit like rmdir. And we're going to, because we're using the R, we're doing it recursively. Okay, so it's going to remove not only the directory, but the contents of that directory, including any directories and their contents as well. So if we scroll down to the bottom, we're going to use -v, because -v does it verbosely. Whenever I do this, and this is personal preference, whenever I do this, I like to see an output afterwards of what was removed, just in case I've done this by accident and I removed something that I shouldn't have. So to come out of this, as usual, just press Control D, or Control C, sorry, to go back into the terminal. And just to show you that we have a foo directory still, let's do an ls that we have that. Do an ls of foo and then tab all the way so you can see that we have all those directories. Remove all of that and type in rm. Now a space. Type in v because we want to do this verbosely, and lowercase r because we want to do this recursively. Now it doesn't matter what order you use this. You could do this in -r and -v, or you could do -r space -v. It doesn't really matter. So in this case we're just going to do r and then v. Now press space and we're going to supply what it is that we wish to remove. In this case we're going to remove foo. So just type in f and then press space, and there you go. So that is going to remove the whole of foo, as well as its directories and any files that may be in that directory. So be super uber careful when you do this. So once you're happy with that command, you press enter, and we can see that a list of all the directories and all the contents that were removed. So the first thing that was removed was 1, so that went foo and then bar and then 1, and then it went removed bar, which is foo and then bar and then foo. So it's going to go in that kind of recursive order when it removes those things. Now if we typed ls here, we won't have anything in this directory because we have removed that contents. So that's how you remove directories, that's how you remove contents of bits and pieces. Like I've shown you, there's other options available for the remove command, some of which we will be tackling later on in this tutorial series. Now, if you found this helpful, if you found this useful, then do give it a thumbs up, show your appreciation, put any comments down below, and I'll try and get back to you as soon as I can. Thanks ever so much for watching. Happy coding, everyone, and I will see you again in the next episode. Cheers. Bye. Hello and welcome to another How to Code Well web chat. My name is Peter Fisher. Today we're going to be furthering our journey into the Linux bash shell by showing you how to move files and folders around. Previous tutorial I showed you how to remove directories and also how to do that in a recursive manner. Today we're going to show you how to move files or move directories from one point to another. So back in the terminal here, we have this window open here. We're in the test directory that we've created before. If I did an ls, which just lists the structure, we have nothing in here. What we're going to do is create a file which is completely empty, and then we're going to rename that file. Now, in the shell, renaming and moving are pretty much the same thing, because when you rename, you are literally removing that name, the original name, and then adding a new one. Same with moving the directory. You can move a directory or a file from one place to the other. All you're doing is renaming where that directory or where that file actually is stored on the file system. So renaming and moving are pretty much the same. You can do it in the same command. I'm going to focus on renaming first, and then I'm going to focus on moving from one place to another. So the first thing we need to do, obviously, is create a file. And we can do this using the touch command. And in doing so, what we do is we create a completely empty file. Let's just do touch, type touch, and then a space, and let's do temp, and we're going to press enter, and that's going to create a file called temp. If you did an ls and press enter, you can see that we have that file already created. Now, what we're going to do is move that file or rename that file that's called temp to something that's called temp2. And to do that, you type in mv for move, and then a space, type in the original name, so temp, and then space, and then type in the new name, which is temp2. Now press enter, and again, we don't have any output, but we have renamed that file. If we did an ls and then press enter, we can now see that that has changed to temp2. Now, like all the other commands that I've showed you, mv also has a series of arguments and options that you can supply that alter the behavior of mv. Let's type info and then mv. You might have to type man mv or mv -- help depending on the shell that you are running. If you press enter, you'll get the help and the usage from that. So mv is move files. And again, if we press the spacebar or page down, you'll get to the next pages and so forth. As you can see, there's a lot of arguments that you can supply. So the -n, the -v, and so forth. So -f is an interesting one because it doesn't prompt you for any confirmation when you're overwriting the destination. But -v is a very helpful one, in my opinion, because it shows you a verbose output of what actually happens. So -v down here is very useful if you want to do something and you want to record where you've put it. So let's go right to the top here, and I'll just show you the actual format for the options. So it's mv and then the arguments or the options, and then it's the source and the target. So the first thing is the source, and then there's a space, and then there's a target. Before all of that, of course, you can supply all of these options. Let's do that again, but this time change the name and do it verbosely. So let's press Control C to come out of this. Let's do an ls to see what we've got, and we have temp2. We're going to use the remove command that I showed you in the previous tutorial to remove that. So let's do an rm and then space tem, and then press the tab a couple of times. We have temp2, press enter, and that removes that. Next, what I'm going to do is just touch and then temp. This time we're going to call that temp1 and press enter. We have that. So just press ls. So there we go. But this time do mv -v and then the source, which is temp1, to the destination, which is temp2. Okay, now press enter, and you can see that we've got some verbose output here. So temp1 and then the arrow symbol here, which denotes that temp1 has been converted into or moved to temp2. So that's renaming. That's renaming a file in the current working directory. Let's see now how we can move that file from one directory to another. Let's do an ls again, and we have that temp2. Now we want to create a directory, and we want to move temp2 into that directory. So as before, we need to use the mkdir command, which is make directory. So let's do mkdir and then type in a directory name. In this case, I'm just going to type in foo and then press enter. Press ls, and we should see that we have foo and we have temp2. Now, at this point, you're probably thinking, how on earth do I tell what is a directory and what is a file? I'm going to be looking at that later on. There are some arguments that you can supply to the ls command, which will tell you what is a directory and what is a file. So we'll be touching on that later on. Just for now, though, remember that foo is a directory and temp2 is a file. So the next thing we need to do in order to accomplish this task is move temp2 file into the foo directory. So let's do mv, and we want to move the source, and the source in this case is temp2, and we want to move that into foo. In this case, we can just type in f and then do tab, and this is going to move the temp2 file into the foo directory. Let's press enter, and you have no output whatsoever here, but if you did an ls, you can see that we have foo, and we no longer have temp2. If you did an ls of foo, you should see in there that we have temp2. So that's moved that into that directory. I'm going to remove that file now and do it in a verbose manner just to show you the difference of output that we've got. So we're outside of that directory. We are still in the test directory, and we want to remove the temp2 file. Let's do rm space and then do foo and then temp2. Press enter, and that's going to remove that file. Type ls again, and we can see that we have just the foo folder, ls of foo, and that will be completely empty. Let's create that and move that again, but this time in a more verbose manner. Okay, so if you typed touch and then temp2 again, did an ls, and we are back to where we were. So we have temp2 as the file and foo as the directory. In order to do it verbosely, what we need to do is supply the -v option. So if we did mv space -v space, supply the source, which is temp2, and the destination, which in this case is foo, and then press enter. And as you can see, we have temp2 and the arrow here, which says that temp2 is going inside foo. So that becomes the new destination. So that was the original source, and that is the new destination. In future videos, I'm going to be showing you more ways to manipulate the folder structure, but I'll be interested to hear what your thoughts are on this course so far. If you could put your thoughts down in the comment section below, that'd be fantastic. If you like this video, do give it a thumbs up. Thanks ever so much for watching, everyone. Happy coding, and I'll see you in the next tutorial. Cheers. Bye. Hello and welcome to another How to Code Well Bash Shell for Beginners course. Today we're going to be talking about how to move out of a directory when you're already in there. Previously, what we've done is we've created directories and we've moved into those directories using the cd command. But what we haven't done so far is moved out of those directories. And also, we haven't done that in any kind of recursive way. So that is what I'm going to show today, how to get out of a directory or how to move from one directory to another. So let's go back into the terminal here, and what we've got is this test directory. If I did an ls, we'll see the directory that we created before, which is foo. So we can move into that, which is cd into foo. But let's say, for instance, we want to move back into our test directory. Well, how do we do that? Well, we know that pwd will print the working directory, which is users Peter Fisher, test, and foo, and that might be different from you because you might have a different folder structure to me. But how do we move through that? Let's say, for instance, we want to be just in the Peter Fisher directory, or perhaps we want to just be in the users directory. How do we do that? Well, first of all, let's focus on how do we move out of the foo directory. Again, what we need to do is use the cd command because we're changing the directory. But we want to move a directory below the directory we're in at the moment. And to do that, we use double periods and then a slash. So what we're doing here is we're saying that we want to move to the directory below this one. Press enter, and now we can see that we've changed back to the foo directory, which is here. If we did an ls, we can see that we have the foo directory like so. Not only can we move one directory down, but we can move as many directories as we want. Do cd and then period again, slash, and then another one, slash, and then perhaps another one, and then press enter, and we are in the root directory. So what we've done here is we've moved 3 levels below the level that we were in originally, and we can see that by 1, 2, and 3 here. If we did a pwd, then we are literally in slash. We would need to jump up 3 levels in order to go to the directory that we were in before. So if we did cd, then users, and again this is going to be a little bit different for you, and then my name, which is Peter Fisher, and then test, that's where we were beforehand. We are now back into that directory structure that we were in before. Notice that we've gone 1, 2, 3 directories here. Notice here that we went down 3 directories, 1, 2, and 3. Now there is a shortcut to this. If we went into the foo directory, for example, we don't have to use the slashes. We could just do ... and that will move us down. So let's do cd ... then that will move us down to the previous directory. Of course, what you can't do is do cd and then ... That's just not going to happen. If you press enter, it's just not going to find that directory. But if you want to move from one directory to another directory downwards, you could just do ... Now, one thing to remember though is when you see something in a script that is just dot or period, that is working within the current working directory, okay? So if you've ever watched any of my Docker tutorials and I've discussed anything about how to copy files from one place to another, and I want to use a relative path, then we would use a dot like this because we're saying that we're working within the current directory. If, let's say, for example, if we did an ls here and we went to foo, we can go into cd ... and then foo, okay, because that is a relative path to where we are currently. So the takeaway here is that dot is a relative path to where you are currently. ... however, moves you down to the next directory below. So cd ... goes down to the home, and if I did cd into test again, and then ls, that's where we were. Now in the future, I'm going to be doing a lot more advanced stuff in terms of the bash shell. We're going to be looking at all the different arguments that change the behavior of those things. I'm also going to talk about how we can distinguish between a file and a folder when we're using the ls command. All sorts of things to do with removing files and directories as well that I didn't talk about in the previous tutorial. So if you're interested in all of that, do subscribe and do watch out for those videos. If you've liked this one, if you found it helpful, then do let me know. Put a thumbs up, put a message in the comment section below. I do appreciate that. Thanks ever so much for watching. Happy coding, everyone, and I will see you again in the next tutorial. Thank you. Bye. In Linux, what you can do is redirect streams from one application or command to another. What do I mean by streams? Well, in Linux, there are 3 streams that can be boiled down. The first one is standard input. That typically is input from your keyboard into a terminal or an application. Standard output is the output that the application has. Maybe it's what it's responded with. Now, the other one is standard error. So if that application returned any kind of error output, that would be standard error. Now, these can all be boiled down to stood in, stood out, and stood error.
Now you can redirect those streams to various different places. You can redirect those streams to different commands. You can even create files with those different streams. They're very useful when you're using loops or you want to find out more about an application that is running. Not only can you redirect streams, but what you can do is pipe the output of one application to another application and another application and so forth. Today, though, we're not going to be focusing on piping data from one application to another. In fact, what we're going to do today is use stream redirection to redirect the output stream and generate a file from scratch. So what we're going to do is dive straight into the terminal here. I'm going to create myself a directory. I'm just going to call it test2. So mkdir to make the directory and then test2. Let's press enter and then let's do a cd, which is changing the directory into test2. And let's do an ls just to list out the contents. And here we can see that it's completely empty as it's a fresh directory that we've just created. Now what I'm going to do, the whole point of this tutorial, is create a file from scratch basically with the contents of a stream, with the output stream. So what we're going to do is just have the content of hello world in a file. Now obviously if I typed in hello world like this, it's going to throw an error because hello world, or the word hello, isn't actually a command. Let's press enter and we have the command not found. So how do I get this text, hello world, into a file? How do I redirect the output here, which is hello world, into that? Well, in fact, there isn't any output here because it has errored. This would be a standard error. Anyway, so what we need to do is actually echo this out to the screen first, and then we're going to see if we can redirect the output to the file. What we're going to use is a command called echo, if I can type it right, so echo like that, and that's going to echo out a string that we provide. So the string here, all in quotes, is going to be hello and then world. And if I was to press enter on the next line, you'll see the text hello world. That is standard output. That is the output of the echo command. We've provided it with some input, which is hello world in quotes, which is the string that we wish to provide, and it's returned an output, a standard output of hello world on a new line here. But how do we redirect this output into another file, or a file that just simply hasn't been created yet? Well, what we would do is redirect the output of the echo command to a new file. So let's type echo and then hello world like we did before, but this time we want to redirect the output, which we can see on this new line here, to a new file. And to do that we use the greater than symbol. This is redirecting the stream. Now we need to provide where we wish to redirect this stream to, and in this case we're going to create a new file. So let's just do test file.txt. Now because this file doesn't exist, it will be created. So let's press enter here and we can see that we haven't got any output at all, not like we had before when we did the echo command. That's because the output of the echo command has been redirected and we've created now a new file called testfile.txt with the hello world as its contents. If you typed ls, you can see that we have this testfile.txt like so. And what we're going to do is just list that out, and I'm going to use cat because that's a very easy command to use to display the contents of a file. I haven't really focused on the cat command yet. Don't worry too much about it. Just type in cat and then test.file.txt. Press enter and we can see that we have that content of hello world. Something to remember is with the streaming, if we were just to run that again, what we're going to do is simply overwrite the content of that file. So if we did the cat again, we can see that we have just the same thing as before. Now obviously the last modified date on that file would have changed, but the contents are just the same. So when we're using a single greater than symbol like this, what we're doing is we're overriding the existing contents of that file, and we're creating the file if the file doesn't exist. I'll just show you. If we instead of hello world, let's change that to hello you, like that, and press enter, and then cat that file again, that's now changed to hello you. So the contents has been overwritten. Now, sometimes you might not want to override content like this. Maybe you want to append the content. Maybe you're doing this in a loop. Maybe you're looping over something and you're pulling out the output, the standard output of a command. In this case, it's the echo command. But let's say you're looping over a command that's returning something after something has happened, and you want to append that to perhaps a log file that you've created, and you want to append that. So you want to record every occurrence of when the echo or the command that you're using has standard output. Now, to do that, you would use a double greater than symbol here. So let's go up a couple of times here. So instead of hello you, let's change that to be back to hello world, if I can spell it like that. And this time do another greater than symbol like that, because what that's saying is that we're going to append that content, that output from this command into this file, which leaves the existing contents of that file. Let's press enter here, and let's do another cat of the test file. We can see now that we have the first one that we had in previously, which is the hello you, and then we have the hello world, which we've just added here. And again, if I was to just press up on the keyboard a couple of times to get back to it, change that from hello world to maybe hello me, and then press enter, cat that out again, we can see that we have a third output here. So that's the difference between a double greater than symbol and a single greater than symbol. It's very important to remember that either one of these will create the file. However, the single greater than symbol will override the file, it'll override the contents of that file, which you might not want to do. You might be doing this, like I said, in a loop. You might be listening to any kind of output and then pushing that into a new file or a log file like so. Now, there's all sorts of other different types of redirects. Like I said, there's all sorts of other different streams. There's the output stream, input stream, and the standard error stream. We've been focusing on the standard output here, the output of the echo command. But you can also redirect input. You can also redirect standard error as well. So, for instance, if the echo command ever threw an error, you can send that error to another log file. So you can have two log files, one with output and one with error. I'll be showing you how to do that shortly in future tutorials. There's also other ways that you can pipe output from one application or one command to another in some form of piping of streams, which I'm going to be showing in future tutorials as well. But if you've liked this tutorial, then do give it a thumbs up, do share it around. And if you haven't done so already, please do subscribe, because like I said, there's going to be more tutorials like this on its way. Thanks ever so much for watching. Happy coding, everyone. And I'll see you again in the next one. Cheers. Bye. In the last Linux tutorial, I showed you how to redirect the output stream of standard output from the echo command into a new file, and that would either create the file if the file doesn't exist, or using the double greater than symbols, it would append the contents to the file. That was focusing on standard output. But what about standard input? How can we use standard input and manipulate a command? Well, that's what we're going to be focusing on today, how we can manipulate commands using standard input. And I'm going to be showing some tricks and some commands that we haven't seen yet. So do bear with me as I go through the tutorial. So let's go back into our terminal here. And the first thing we're going to do is show you how to use what's called the word count command, which is WC. So if I did info of WC here, we can see that we have the information. You might have to use man to get the man pages to get this information up. And what we've got here is the description of the WC utility. It displays the number of lines, words, and bytes contained in an input file, in a file. If we scroll down, we can see there's different arguments that are needed here. So there is -L that we're going to use. That's that displays the number of lines. -C is the number of bytes, and so forth. We're not going to worry too much about the other arguments. We're just going to worry about the -L for now. What we're going to do is find the number of lines within a file. And I'm going to be showing you how to do that in various ways. One of those ways is how to use the contents of a file and redirect that as standard input into this WC command. Okay, so press Control-C to get rid of the info here. I'm just going to clear that down to give us some more room. Okay, so if I did an ls, we can see that the file that we created in the previous tutorial, the test file.txt. If I did a cat of that, we can see the contents here. Now we can see that there's 3 lines in this file. There's the hello you, hello world, and hello me. But pretend that this file is quite huge. It could even have a couple of thousand lines in here, and the WC-L command, or the WC command with the -L argument, is great for displaying and counting those lines very quickly. Now what you can do is just do an WC-L of that and just supply test file, press enter, and you can see that the output is test file.txt, that's the name of the file, as well as a number which is 3. So that's fantastic. That's what we want to do. But how about doing that without returning the name of the file? Maybe that's just something that we don't want. Maybe all we want is the number. How do we go about doing that? Well, one way we can do that is by redirecting the input stream of the contents of testfile.txt as the first argument of this command, the WC command. So what we can do is do the WC-L again, but like last time we had the greater than symbol, that's for standard output. We want to use the testfile.txt as standard input. And so what we need to do is the less than symbol. The opposite of standard output is standard input. So this is the less than symbol. Then do a space and put in where we want the input to come in from, and that is the test file. So just type in TES and then tab to bring that back. Press enter, and what we've done is, because we've supplied that as the standard input, we're now removing the need of finding out what the actual test file is called, and therefore the output here is simply 3. And so what we've done is used the contents of testfile.txt as the standard input, and we've given the standard input, or redirected it, I should say, into this WC command. Therefore, we only have 3, because we don't need to know about this, the actual name of the file. Now, this is very handy if you've got any kind of scripts and you want to analyze the contents of a folder. And so you would loop through and then run this WC command and supplying the file as the standard input, and that would return a series of numbers. So that's using standard input. Now, I showed standard output last time, but how about combining the two together? Perhaps we want to create a file that just has the number of lines of another file within it. So let's create another file, and its contents will be the number of lines the other file has. So for example, we could do WC-L to get the number of lines, passing in that as the standard input, and make sure you have a space between the two. And what we would like to do is redirect that output, number 3, into another file. And so what you could do is redirect the output stream to, say, test file2.txt, like so. If we pressed enter though, we don't get any output. Now, if I did an ls, we can see that we have two files here. So beforehand, we only had the test file.txt. Now we have the test file2.txt. What do you think is going to be in the second test file? Let's get that out and see. Test file 2.txt. That is number 3. That is because what we've done here is we've passed in testfile.txt as the standard input into the wc command with the -l argument. So that's going to return 3. So 3 would be the standard output of that sequence of commands. And what we're doing here is redirecting that to the testfile.2 or testfile2.txt. The file hasn't been created, and therefore it will be created, which means that we can update testfile.txt with another line and then run that command again, and that will be updated. So what I'm going to do is add another line into the original test file.txt, and we do this like we did before. We do echo, putting in, I'm going to do hello again. Now remember, what we want to do is we want to keep the original contents of the test file, and so we need to append test file, which is the double greater than symbols, and we're doing test file.txt because that's the original that we want to do. Let's press enter, and let's just do a cat to make sure that's in. So let's do a cat of test file.txt. Now we have hello again. That's the new line that we've just added, which means that if we ran this command, we should get 4 instead of 3. So let's go up again on a couple of times to bring out that one. Now be cautious here. You want to ensure that that is a double greater than symbol because we're appending it. We don't want to get rid of the original. So press enter on that one, and let's cat out test file 2.txt. And here we have 3 and we have 4 because 3 was the original, 4 was the new one, so we've appended that. If we went up on here a couple of times, we removed the second greater than symbol. What we're doing here is we're overriding the contents of that file. Let's press enter, and let's just cat that out again. So bring that up to there, and we can see that now just has 4 as its contents. So that's input and output redirection. What we've done is we've added the testfile.txt as the standard input of the wc-l argument. So wc is word count, using the -l argument here, which is just printing out the lines. We're taking the standard output of that and we're redirecting the standard output into the testfile2.txt. Now, when we started this tutorial, the testfile2 didn't exist, and therefore it's being created. Up here, we're using the double ampersand, and that means that was appending the contents to the original contents, and therefore we would have 3 and 4. Here, we've only using a single greater than symbol, and therefore the stream has been overwritten, or the original content, has been overwritten with the new stream. As I've mentioned, I've got lots of other tutorials regarding Linux and other things as well, so please do subscribe if you haven't done so already. If you found this tutorial useful, please do like it, please do share it around. Thanks ever so much for watching. Happy coding, everyone, and I'll speak to you again in the next tutorial. Cheers, bye. In the previous Linux tutorials, I showed you how to manipulate the redirection of standard input and standard output. Today we're going to be focusing on piping the output of one command to another command. So we're not going to be playing too much around redirection of streams. We're going to be playing around with how to pipe the output, the standard output from one command into another command. Now we're going to keep it nice and simple to begin with, but then we're going to move on to some more advanced topics. So let's dive right back into the terminal here. And if I did an ls of this directory, you'll see that we have the test file and the test2 file that we created in the previous tutorials. Now what I'm going to do is list these files out and manipulate the return of the ls command. Now if I just did an ls here like I've done before, we can see that we've got those two files. If I did an ls -l, that will bring us back some more information. Imagine though if this directory was full of different files and we needed to find a way of sorting those files. Perhaps you've been given a challenge to find perhaps the three most recent files that were ever created and supply those files in perhaps another file or send those as an email or something like that. So the way we can do this is by adding files to this directory. Let's just hit touch, just type in touch like this, and what you can do is just create a whole bunch of files. In this case we're just going to go through the alphabet, so A space B, then C, D, and so forth. This is going to create a file for each one of those things that you've added in. So we're going to create a file for A, a file for B, C, D, and E. What I'm going to do is just skip forward and go X and then Y and then Z, so we're not going to go through the whole alphabet here. Let's press enter and let's do an ls. Now you should see this kind of output here where we have all of those files created. If we did an ls-l, then you should see them listed like so. So the first one we created here was A, and then the last one was a Z, and you can see the timestamps have all happened on the same minute. So I'm going to wait for a few minutes and then add another one, and I'll do that in just a moment. Now I just want to talk about the ls command in general. The ls command is very powerful because we can see different parts of the output here. We have the user that created the file, as well as the user who can access this file. This here is the group. So a user will have a group. We also have the date. On the left here, sorry, we have these dashes, RWs, and so forth. This is file permissions. Now I'm going to be talking about file permissions in a separate tutorial later on. The number 1 here is that is saying that is one file. Okay, if we had a directory with other files in it, then that would be a number of a count of how many files in that directory. What I can do is just do an mkdir and do a temp like so, and then I'll do a touch of A, B, and C within temp. So in fact what I need to do, sorry, is go touch and then temp A like that, and if I did an ls, we can see that we have the temp directory, and I'm also going to just do up again and do B, up again and go C like that. Now if we did an ls, we can see that we haven't added anything into this parent directory, but if we did an ls of temp, whoops, we can see that we have A, B, and C. Now if I did an ls-l, we can see that that has changed to be 5. Now even though we have 3 parts or 3 files within this directory, we actually have that set to 5 because it counts not only itself but also the parent directory. Excuse me. So that is itself 1, and then we have 2, and then 3, and then 4, and then the current directory itself counts as 1. Okay, so that's what those columns mean. So enough time has passed, so I'm going to create another file. I'm going to call this P. So let's just do touch and then P. And the reason I was wanting to do this is if I did an ls-l, we can see that P was made it on the 1729 here. So we can see all of this is 26, 1726. That was what I created, 1728. That was a minute ago. That was the directory. You don't have to worry about that. And then the rest were 26. So now I've got something to actually play with in terms of time. So going back to our previous challenge that I mentioned, finding the files, or finding the 3 files that were created recently, the most recent 3 files created recently. And imagine that this directory has hundreds and hundreds and hundreds of files. How are you going to do this? Because the normal default way of sorting through ls, as you can see here, is via a dictionary. So A would be the first one, and then B, and then C, because that starts in alphabetical order. But P, which was just created just a minute ago, is down in the middle. So you can imagine that, if you have hundreds and hundreds of files within this directory, and the file that you just created that you want to play with or want to output is smack bang in the middle, it's going to be quite difficult to sort through the ls command from just its raw output. Now what I'm going to do is just clear down the screen, make some room. I'll talk about the clear command later on, but that just wipes the current buffer. And if I did an ls -l again, just for a reference, the way we can order this is using the -t. Let's do an ls -l and then t. Now this could be -t, or this could just be t as shown here. Let's do an enter here, and we can see that now it's ordered by the time. So we have 1729 as the one that's just come through, right? That's the first one that is shown. That is the most recent file. Of course, as I think I've shown you before, we can reverse this order. So if we did an ls -l and then did a t and then an r, so we're going to reverse the order, we've now got the file that was created, or the oldest file that was created, and that was the test file that we did in a previous tutorial. Okay, that's all well and good, but how do we return only three files, the 3 files that are most recently created? Well, we can use the ls command with another command. So we can pipe this output, this standard output, to another command. The command that we're going to use is called head. Now head will return the contents in top order. There's another command called tail, which will return in the bottom order, and so forth. We're going to focus on head and tail in more detail later on. Don't worry about it. Just remember that we're going to be focusing on head today. And if I clear down the screen, so let's just run that command again. So ls -l and t, just for reference. Now we want to return only 3 rows here. So we want to return p and temp and a. How do we go about doing that? How do we only return those 3? Well, what we can do is pipe this standard output to the head command. Okay, the head command, I'll be focusing on that in far more depth later on, but that's going to return the contents at the top of this output. So here we go, and we can do that using ls -lt and then pipe that to head, and we're going to use the argument of n, which means that we're going to tell it how many lines that we want to return, and in this case we want to do 3. And when we press enter, we'll have 3 lines returned. But notice that we have only 2 outputs here, 2 lines here. Well, we've actually got 3 because we have the total right there. So in order to make this work, we need to do -n and then 4, and that's going to return 4 lines. So that line, this line, this line, and this line. And we can see that these are the files that were most recently created. So they have the date of 1729, 1728, and 1726. Of course, if I was to reverse this order, so let's just go up on here and put in an R, oops, like so, we can see that that is the output in reverse order. Now, the challenge was to actually put this in a file that we can email to perhaps our line manager, our boss, or whatever. They've gone and said, can we get the most recent 3 files in this directory? Well, we can do this using standard redirection, using the standard output. And what I'm going to do is just clear down this screen, make a little bit more room, go up here. So we have those lines. And what we can do is we can use the standard output of this, and we can return that and create a file. So in this case, what I'm going to do is just do test file 3.txt, and that's going to create the file, the test file 3, because it hasn't been created before, with this output. Before I press this, I'm just going to talk a little bit about what we're actually doing here in a little bit more detail. So the ls command will list out the contents of a directory. -l will list it like so. So we have the file permissions, the count of objects, the user, the group, the file size in bytes, and so forth, the timestamps and the file names, and blah blah blah. The -t will sort that in time, so that is doing it by creation date and modified date and so forth. R will do it in reverse order, so we're going to get the files that were created originally, so we're not going to get the new files that we created. And we're going to pipe that to head, because we only want to get the first 4 results. So in this case, we get this, which is the total, and we get these 3 outputs here. So that's what -n, because we're doing it, we're saying only supply these number of lines. In this case, it's 4. We're then going to redirect that stream, that output stream, to a file called testfile3.txt. Now, testfile3.txt doesn't exist at the moment, so it's going to create that. So let's press enter, and then let's just do a simple ls, and we can see that we've got testfile3 here. Let's do a simple cat of testfile3, and that is exactly the same output as what we had at the top here. So that's piping. And something I should say about piping is that you can pipe a whole, there's no limit to how many applications or commands you can pipe the output to. So you could pipe this to another application and so forth. So if, for example, you wanted to sort this information out in a different way, you might want to send that to, say, the sort function. You might want to return the 4 records right at the bottom rather than at the top. I'll quickly show you how to do that now. Let's just do a simple ls -lt, and we're going to do it in reverse order again. So perhaps we want to return this lot rather than the stuff at the top. And I guess what we could do is, there's no point in having it in reverse order. So it's let's do this stuff. So we want to return maybe all the way from test file to y here. So beforehand, we returned the stuff at the top. And what I'll do is just run this without the R. So like so. And because the test file 3 has already been created, it will override that. Let's just do a quick cat of that. File, test file 3. There we go. So that's the contents that we've got. Now we want to return the stuff at the bottom. Okay, so what we can do is say go up a little bit. Instead of head, we want to get tail. So the tail like so, because the head will be the top of the contents, the tail will be at the bottom of the contents. Let's press enter here and then do an ls. We've still got all the files, that's fine. Let's cat that test file 3 like so. And now can you see that we've got the stuff at the bottom rather than at the top? Now that doesn't really make much sense, having putting all those files, that content together. What we can do is something like this. Let's just clear down the screen, make a little bit of room. Let's just move that back up. Let's say that that was good so that was head, like so. Let's cat that. So we're going to cat that back to test file 3. And let's actually put something in between. Let's do echo. Let's do let's just type in tail, like so. And we're going to do two greater than symbols because we're going to append it to test file 3, like so. Let's cat that. So this is now test file 3, if I can spell. There we go. Right. And then what we want to do is go up a few more, and then instead of head, change that to be tail. And of course we want to put in double greater than symbols because we're appending it to the file, and press enter. Now do a cat of test file 3. Whoops, test file 3, there we go. And you can see that we have the stuff on the head and the stuff at the tail here. And then you can send that off to your manager or whoever and say, well, the stuff at the start is the files that were most recent, and then the files that were less recent at the bottom. And that's how you do it. That is how you use the pipe symbol as well as the redirection. Now, this is extremely powerful, especially within bash scripts and so forth. We're going to be focusing on bash scripts definitely in the future, so do stick around for that. If you found this tutorial helpful, then do show your appreciation, give it a thumbs up, share it around, and if you've got any comments or queries or questions, or if you've got an idea of something that you would like me to demonstrate in future tutorials, then put it down in the comments section below, and I'll get back to you as soon as I can. If you haven't done so already, please subscribe, because I've got more tutorials like this coming up in the future. Thanks ever so much for watching. Happy coding, everyone, and I'll see you again in the next tutorial. Cheers. Bye. In the previous Linux Bash tutorials, I've been showing you how to use the cat command to output the contents of a file. However, the cat command is actually quite a versatile command, and it can do so much more than just output a single file contents. In fact, cat stands for concatenate, which means that you can link files together to display a single output that you can either stream and redirect to another file, or just simply have that output on the screen. There's other things you can do with the cat command as well, including displaying the line numbers, and that is extremely useful for programmers. Right, so the first thing we're going to do is take a look at the arguments of the cat command, and then I'll demonstrate how to list the line numbers out, and then we're going to talk about concatenating the files together. So back in the terminal then, if we did an info of cat, or you might have to do man cat or something similar, if we press enter here, and we can see that cat is concatenate and print files. Okay, files plural, you can actually print more than one file at a time. Scroll down here and we can see that there's a couple of options. -b will number the non-blank output lines starting at 1, whereas -n will number the output lines starting at 1. I'll show you the difference between the two in just a minute. -e will display non-printing characters, and -s will squeeze multiple adjacent empty lines together, causing the output to be single-spaced. I'm going to be showing you those in just a second. We've also got -t and -u, as well as -v here, which is all about displaying non-printing characters, or disabling the output buffering, or to display non-printing characters using the -v option, and other similar tab characters too. Not going to worry too much about those in this tutorial. Let's talk about displaying the line numbers then. I'm going to press Q, or you could press Control C to come out of this info page, and let's just run the cat command like we've done before. So type cat, and in this case we're just going to do test file.txt. We're in the same directory as we've always been in with these tutorials. So test file is the first file that we created in this Linux tutorial series. If you haven't done so already, do check that out. Let's press enter here, and we can see that we have these lines, these hello you, hello world, hello me, and hello again. This was from the tutorial that I demonstrated how to redirect standard output to append this file, create this file, and then append contents to this file. Now imagine this file is pretty long and you want to display the line numbers in this file. Now to do that you would use a -n argument, because that's displaying the output lines starting at 1. So let's do a cat -n of test file, like so, .txt. And here we can see we have the same output, but this time on the left hand side here we have the line numbers 1, 2, all the way down to 4. Let's add another line into this file, but this time let's create an empty line and see what happens. So let's do an echo, and I'm going to use the standard output redirection to put in an empty string into this test file. And again, it's double greater than symbols because we're appending to this file. So let's just do test file.txt. Press enter here and you won't get any output at all. But if we just did a simple cat without any arguments of the test file .txt, we can see that we have this empty line here. Now if we did the -n again to list the output lines, we're also going to count that. So let's do cat -n of the test file .txt, and you can see that we have 1 to 5 now. But what happens if you only want to count lines that have contents? You don't actually want to count lines that are blank and empty. Well, that's where the -b command or argument comes into. So let's do, first of all, let's just show you. Let's do info of cat again and scroll down here a little bit. We can see -b number the non-blank output lines, non-blank being not empty. Okay, so they will only count the lines or display the line count to a line that isn't empty. Again, press Q or Control C to get out of that. Clear down the screen just to give some room. Let's do a cat -b this time of the test file .txt and press enter. Now notice we now only have 1 to 4, and this fifth line that's completely empty doesn't have a line number. I'm just going to append another line that actually has contents just to show you that the difference between -n and -b. So I'm just going to scroll up a bit on the arrow keys here just to get to the echo, and I'm just going to put in a line, and we're going to call it just test or anything you want. Press enter and then use the -b in the cat command. Press enter and we can see that we have 1, 2, 3, 4. We've skipped a line because that is an empty line, and we've gone straight to 5. Now if we didn't use -b, if we used -n instead, then we would count that line in the file. Let's do that. Let's do cat -n and then test file, like so, test file.txt. And here we can see that we've now got 6 lines, because we are indeed counting the 5th line, which is empty. So when you get asked, can you count the lines in this file, you need to find out whether or not it's the lines that actually have any contents on them, or if they don't have any contents at all. Okay, so let's clear down the screen. The next thing I'm going to show you is how to concatenate files together to give us a single output stream. Okay, so concatenation means linking things together, and we can link as many files as we wish. If we did an ls-l here, we can see that we have lots of files, but lots of them have 0 bytes, like this one, for instance. We're just going to quickly create another file. Let's just do an echo, and we're just going to add, this is another file, and we're going to send that output stream. We're going to redirect that to test file.t4, I should say, .txt. Okay, let's just quickly cat that out just to see what we have. Test file 4.txt, like so. Okay, let's clear down that screen. Now what we want to do is we want to link the original test file and the test file 4.txt's together in a single output. And we would do that using the cat command, and we pass in the first file that we wish to use. So in this case it's test file .txt, and then a space, and then the subsequent files that we wish to concatenate. So in this case, let's do a test file 4.txt, and when we press enter, we're going to get a single output where both of those files are joined together. Press enter, and now we've got hello you, hello world, hello me, hello again, the blank space, the test, and this is another file. Now this is another file is from the test file 4. Everything above is from the test file.txt. Now if I was to say let's reorder this, so instead of putting test file.txt first, we did test file 4.txt. Now press enter, it is the other way round, it's the other order. And of course we can use the arguments of cat to display line numbers as well. So let's scroll up and go straight to the end here, and we're going to use, in this case we're going to do -b and press enter, and now we've got line numbers. This is extremely useful, especially if you're a programmer and you want to find out the line numbers of a file.
In the previous Linux tutorials, we've been using the ls command to list out the contents of the current working directory. Now, by default, the ls command will not display hidden files. But what is a hidden file? Well, hidden files are very useful, especially in programming, because many hidden files hold configuration and settings that tell the application, or perhaps the server that the application is sitting on, how to behave. So, for example, you could have a .htaccess file with perhaps some values for changing PHP settings and also manipulating your web server. Now you could also have hidden files in Git, so you can have a git ignore file that has different rules and patterns on what other files and folders are hidden from the Git repository. Also, you could have a Docker ignore file that hides things from the build context. Also, in Linux, there are hidden files that allow you to configure and export environment variables onto your working path. We're going to be dealing with bash environment variables later on. Today, though, we're going to be creating hidden files and showing them and hiding them from the working directory. So let's go back into the terminal here. And we're in our usual directory, the test2 directory. If I was just to type ls like standard, we have the list of the contents that we have. And if we did an ls-l, we can get the long form information out. Now, a hidden file starts with a period or a full stop. That means that that file is hidden by default. So what we're going to do is create our own little hidden file and then see how we can show that in the ls command. So what we're going to do is just create ourselves a hidden file. Now, hidden files, like I said, start with a period symbol. So we're going to use standard output redirection just to create a new file. So in this case, we're just going to do echo, and then we're going to add the contents of this is a hidden file, like so, and we're just going to stream or redirect that output stream to a hidden file. Start with a full stop and then just do hidden
hidden file or whatever you would like to call it. Now, you can leave it like that, or you could have a file extension. If you've got a htaccess file, it is a .htaccess file. So let's just press enter like that. Now, let's clear down the screen just to give us some room, and let's just do an ls. Notice that the hidden file isn't shown in the ls output. It's also not shown if we did an ls-l just to get the long form contents back. So it's not shown here. That is because hidden files are hidden by default. That's the whole point of having a hidden file. Now, with the ls command, we can provide more options to the command to show or not show the hidden files. Let's have a look at the help information for the ls command. So type info, or you might have to try man if you're using a different distribution. So info ls to get the information back of the ls command. So ls list directory contents. You can see here there is an awful lot of arguments and options that you can supply to the ls command. Scroll all the way down a little bit. We are focusing today on the -a, which is the capital A, and the lowercase a. Now, the capital A option will list all entries except for dot and dot dot dot. And that's always set for the super user. The lowercase a, however, includes directory entries where their name begins with a dot. So let's use that like a switch to turn on and off the hidden files. So as always, press Q or Control C to come out of that. And let's just clear down the screen to give us some more room. Now, what I'm going to do is just type in ls -lowercase a here. So press enter, and we can see that we have these 3 new entries. We have a single dot, 2 dots, and then the dot hidden file. Now, what does that mean? Well, the hidden file is obviously the file that we have created. This means that that is the current working directory. This means that that is the parent directory. So, for example, if I was to do cd to change my working directory into a period here, into the full stop, so into this one, that is just going to go into the current working directory, which we've done here. Now, if I was to do a cd dot dot, that's going to come out of this current working directory and go into the parent directory. So press enter here, and we are now a directory above. So let's go back into that. So cd, and I've called this test2, and we're back into the directory that we were just in. And of course, if I did a cat of dot hidden file like so, we can see the contents of the hidden file that we created before. Now, again, if I did an ls command here, we aren't going to get those 3 entries. But what happens if we just want to get the hidden file and we don't actually care about these 2 entries here? Because, you might be running a script and you might not care about those 2 things. You might have to add some conditions, some functionality in order to prevent those 2 things from actually interfering when you're looping through the contents of your directory. Well, that's where the capital A option comes into play. Let's just clear down the screen, make a little bit more room. Let's do an ls -capital A here. Now, the -A will remove the dot and the dot dot entries, so we are just left with a single dot. So we have the hidden file here, but we don't have the previous 2 entries that we had. Again, I can just simply do a cat of dot hidden file like I've done before, and there we go. Now, we can obviously add multiple options to the ls command. We could do an ls -a, we could also do a -l, or we could do an a and then an l, or an l and then an a. It doesn't really matter which order these things go in, so let's just do an ls -la. And we have the long form output as well as these two entries. Now, notice there is a D at the start of these 2 file permission masks. I'll be talking about file permissions later on in this course. Now, the D means that it's a directory. So this dot means that it's the current directory, and then the 2 dots here means that it's the parent directory. And of course, the hidden file doesn't have the D at the start, and the temp directory does have the D here. I'll be talking about those, like I said, in far more depth later on.
So just to recap, let's clear down the screen. Let's do an ls-a, and that's going to list out all the 3 entries, including our hidden file. If we did an ls-A, we are only going to get the hidden file, like so. And then an ls as standard will not show the hidden file because a hidden file is hidden by default. If you found this video helpful, then do show your appreciation, give it a thumbs up and share it around. If you've got any suggestions for future videos or tutorials, put your thoughts down in the comments section below. As always, everyone, happy coding, and I will be seeing you again in the next tutorial. Cheers, bye. Today we're going to be focusing on the very basics of a Linux file permissions. And I say the very basics of because file permissions in Linux is actually quite a very complicated topic. In fact, it warrants its own course. There's so much involved. And also, I kind of need to have a whiteboard to demonstrate all the bits and pieces to do with octal codes and so forth. So today we're just going to sort of skim the very surface of file permissions in Linux. I'm going to be showing you some easy ways to change the permissions as well. So let's go into the terminal here, and what we need to do is just do an ls. We're in our normal test2 directory. Here we can see the contents of this directory. Here we've got all these files, and we've got a couple of directories too. If we did an ls-l though, we've got the long form output, and that's what we need to play with today, because we need to get hold of this stuff here on the left hand side. Now this is 10 characters that represents something to do with the file or the directory, basically the contents of this output here. Now the first character within this string is what's called a type code. Now normally these are just set to a dash. Dash means that it's a normal file. However, here we have a D. Now, I think I've mentioned in a previous tutorial that a D represents a directory, but we can have all sorts of different type codes. We can have S, we can have L for symlinks, and other things as well. Now, I'm not going to be focusing on those today because that's a completely different rabbit hole to go down. We're just going to be focusing on the last 9 parts of this string. And we're going to be focusing on the verbose output of this. This actually represents what's called an octal code, but we're not going to be playing around with that too much today because that's probably enough for another tutorial or even another course. What we're going to be focusing on is the difference between R, W, X, and user group and world access. Here we have 9 characters, like I've mentioned. These 9 characters are split up in 3 groups. The first group is the user. The second group is the group access. And lastly, the third group here is the global or the world access. What we're going to do is play around with this file here, the test file. And at the moment we can see that it doesn't have a special type code. It is literally just a normal file, which is fine. We then have R and then we have W. That is the file permissions for the user that created and owns that file. We then have a blank space here, or a dash. That means that we don't have executable rights. Basically, these 3 in each of these blocks represent read, write, and execute, or R, W, and X. The next 3 spaces are the group access. So anyone with a group access of staff, because this is the group column, this is the user column. Anyone who is a staff group in the staff group can have read access, but they cannot have write access or execute access. Now that's the same for the global group or the world group. This means that anybody on the system can read that file. Now you have to be very cautious here, as you've probably guessed, because you should only set the permissions to that of the user or the group or the world if you need to, if they're required. Don't just give everybody access because perhaps that fixes and solves a problem. That probably will create you another problem down the road. So let's just focus on the user for now. the user has read and write. But what about execute? How do we give him execute permissions? Perhaps this test file is a script that needs to be ran. Well, to do that, you use the chmod command. Chmod will change and modify the file permissions. So let's type chmod, and what we need to do is pass in what's called a permission code. Now there's 4 permission groups that you can choose from: user, group, world, and all meaning all of them together. So we're just going to be focusing on the user permission code for now, so that is U. And we can add and subtract and equal the permissions. So what we're going to do is we're going to add the execute permissions. So we're going to put it in a plus symbol and X for execute. We're also then going to give the name of what it is that we want to change. So in this case, testfile.txt. Press enter here and then ls-l to get the output again, and you can see that we've added X here, which represents the executable permission to the users section within this permission slot. So we have read, we have write, and now we have execute. Now, like with adding permissions, we can subtract permissions as well. So let's do a chmod and let's remove the execute permission. So we need to go U and then minus and X. Make sure you don't have any spaces in between these things, otherwise they just won't work. So chmod U minus X. And again, we give the name of the file that we want to change. So this is testfile.txt. Press enter and then ls-l. Now we can see that we've removed the execute permissions from here, which basically brings it back to how it was beforehand. Like with changing the user, we can also change the group. So we can do chmod. Let's do group, so that's G, and we're going to plus W and X to the test file. Now W and X, W means write, X means execute. So let's press enter here and then ls-l to bring that back. And here we've added write and execute permissions to the group. So let's go and change the global permissions. Let's just clear down the screen first to give us some room. So do a chmod, put in O because O represents the global, the world permission code. And we're going to just give you executable rights for the test file.txt. Press enter, then ls-l, and we can see that we've given you execute permissions. So test file now has read and write permissions for the user. The group can read, write, and execute, and globally you can read and execute. Not a very good set of permissions, I should admit, but permissions nonetheless. So that's adding and subtracting permissions from the permission codes. What we can do is actually equal a permission code to another permission code. So right now we have read and execute permissions for the global permission code. We want to change the user permission code to also equal that of the global permission code. So the user we want to have read and we want execute, but we don't want to have write perhaps. So let's do that now. Let's do a chmod. Let's do user, and we're going to equal that to O, which is global. And we're going to do a test file, because that's the thing we want to change, .txt. Let's press enter and then do an ls-l. And now we've changed it so we have read and execute, which is on the user, which is just the same as read and execute on the world permission code. Now, all I've done in this tutorial is just change the permissions from one thing to the other. What I haven't actually showed you is the effect that this actually has on the file. So, for instance, we have, for the user here, we have read and we have execute, but we don't have write. So let's go and try and write to that file and see what happens. If I've done this correctly, of course, we should get a permission denied error. So let's just clear down the screen and let's do an echo, and let's do this is a new line, and we're going to append this stream. We're going to redirect that to the test file, testfile.txt, and we're going to press enter, and we've got a permission denied issue here. That is because we've removed the write access from this file for the user. Let's do an ls-l to see what else we've got. We've got read access at the moment, so we should be able to do a cat of test file, testfile.txt. Press enter here and we can read that. What happens, do you think, when we remove the read access? So let's do a chmod. Let's do u-r of testfile.txt. Press enter. Let's see if we can do a cat of that again. Pressing enter here, and we have a permission denied error. So that's the effect of changing the permissions for the user. It'll be the same for changing them if you're in a group or if you're accessing it globally as well. Now lastly, what I'm going to show you is how to change multiple permission codes at once. So let's just clear down the screen, make some room, do an ls-l because I've gone and forgotten what permissions we're running now. So we have, what's that, execute for the user, and then we have read and write and execute for the group, and just read and execute for the world. So let's go and change a bunch of these things together. Let's do chmod, let's do user is equal to, say, just R, because we only want to read that. We're going to put in a comma symbol here, and we're not going to add a space at all because that will screw up this command, but we're going to give another permission code. Let's say group, and at the moment the group has what's that, read, write and execute. Say the execute off of U, and we're also going to change the global permission code, and we're going to perhaps give O, because that's global, going to give that perhaps the right permission too. So let's do a space here and put in what it is that we want to change. So in this case it's testfile.txt. Press enter here and then ls-l and see what we've done. So we've chmoded and we've given the user only R, which means that that is readable, and we've equaled that, so we're saying that that group permission section should only be R. It shouldn't be anything else. So we've removed what it was previously. So here we have R for the user. We don't have write and we don't have executable rights for the user because we've only set it to be R here. Okay, for the group, what we've done is we've removed the executable permission. So we have R and W. R and W was what we had before, but we also had execute. So we've removed that from the group. And what we've done for the global is we've set that to W as well. So we've given write access to the global access. Now, what we can do is set all of them together, because I said before with the permission codes, there's actually 4 permission codes. The 4th one is A, which represents all. So let's go and set everything to just write access. So what we do here, let's just clear down that screen, make a little bit of room, ls-l, just to show you where we are. Let's do a chmod, and let's do an A, and we're just going to equal that to R, and we're going to do testfile.txt. Press enter here, and then ls-l, and everything should just have R. So the user, the group, and globally, you should only be able to read that file. And again, if I did a cat of test file, because I am the owner of that file, I should be able to read that file, but I shouldn't be able to write to it. So I shouldn't be able to do this, echo, and then foo bar, and then append that standard output stream to test file. This should give me an error, testfile.txt, which it does. I've mentioned that the Linux file permissions is an extremely complicated topic, and it is. All of that was just done using the chmod command, but there's so many more commands to do with changing file permissions, file groups, and all sorts of things as well. And we might be looking at those in future courses or future tutorials. If you found this tutorial helpful, then do show your appreciation, give it a thumbs up, do share it around. If you've got any comments on what you would like me to do in future tutorials, put your thoughts down in the comments section below. As always, thanks ever so much for watching, happy coding, and I will see you again in the next tutorial. Cheers, bye. In this Linux Bash tutorial, we're going to be focusing on the Linux cp command, which stands for copy files or copy and paste files. Not only can it copy files, but it can also copy and paste directories and the contents, including the subdirectories and their contents also. Now, the cp command has quite a few options and arguments, and I'll be going through some of them in this tutorial. Let's go back into the terminal now, and let's just do an ls of the test2 directory here. As you can see that we have the usual contents that we've always had. If we did an ls-l, we can see some more information about these. Now, the cp command, as I said, will allow you to copy and paste files and directories, but in order to find out more information about the cp command, type info, or you may have to do man and then cp. Press enter on that and you'll get the usage, the man pages or manual of the cp command, and it stands for copy files. Now, as you can see here, we've got quite a few options that you can supply, as well as the two required parts of the command, which is the source file or the source directory and the target file or target directory. This allows you to define a source and a destination, which means that you can also not only copy the file or directory in the current working directory, but also move it to another directory if you wish, which I'll be showing you how to do in just a second. First though, let's scroll down a little bit further and have a look at what options are available to us. So we have -a, -f, and -H. Now, we're not going to follow a lot of these in this tutorial because I'm only going to be touching on the basics of cp, but what we will be dealing with is -R, because that deals with the recursiveness that allows you to copy and paste the directories within or subdirectories within the directory and their contents as well as -V. -V allows us to show a verbose output when this cp command is running, and that's very useful just to double check what you're doing. Whenever I do commands like this, especially the cp, the rm and the mv commands, I always like to have a verbose mode showing me exactly what I'm doing. So to come out of that, press Q or Control C. I'm just going to clear down the screen here to make some room, and then I'm going to do an ls-a, -L, and we're going to move the test file.txt. We're going to copy that to another file in this directory. So cp, the source is going to be test file, like so, .txt, and the destination is going to be test file, and I'm going to call this test file 6 because we don't have a sixth one yet, .txt. Press enter and you won't get any output, but that's fine. If you pressed ls-l, you can see that we have test file 6 and obviously the test file. Now notice that the access times haven't changed at all. However, the bytes are exactly the same, so we have 62 bytes on each one of these. The file permissions are also the same, so we have read for the user, read for the group, and read for global, and it's the same with the test file up here. One would say that if you did cat of test file.txt and also test file 6.txt and then press enter, we should see a repeat of that file. So we've got hello you, and then we have hello world, hello me, and so forth. So we've concatenated the output there. So that's copying and pasting files. How about directories though? Let's clear down this screen and then do an ls-l again. We have one directory here called temp. Let's see if we can copy that temp directory. So let's do a cp and do temp, and we're going to copy that to let's say temp2, for instance. Press enter here and we're going to get an error because temp is a directory and it's not copied. So the default copy and paste functionality in Linux, or in Bash at least, is to copy files. If it's a directory, you need to specify that you wish to copy a directory. This is where the -R comes into play.
So let's jump up here and then do a hyphen capital R for the option of the CP command. Press enter and we won't get any output here because we haven't put verbose mode on. I'll do that in just a second. But if we did an ls hyphen A or hyphen L, so here we can see that we have temp and temp2. These are directories because we can see that the file type code here is D. Okay, D meaning directories is something that we've discussed in a previous file permissions tutorial. But also what we can do is an ls hyphen L and also capital F, because what that's going to do is add slashes to the end of these to denote that they are directories. Okay, so as before, they're exactly the same in terms of size. However, the timestamps are different. Now, what we can do is display what's actually going on, because there's actually quite a lot of stuff in here, 170 bytes compared to the standard 62 that we were playing with beforehand. So what is it that we've just copied? Well, if we did an ls of temp itself and then did an ls of temp2, you can see that what we've done is we've copied the contents of that directory, and also those contents is if there is any. But how do we do this, as a verbose output as we're doing it? Well, let's do a clear of the screen. Let's do a CP hyphen capital R lowercase v because we want to do it verbosely. Again, we can do V and R in any type of order. We can do V and then capital R like that, or we can do capital R and then V. Doesn't really make a difference. So we're doing it recursively and we're doing it verbosely. We want to copy temp and we're copying that to temp. We're going to call that temp3. We press enter here and you see what we've got is an output. Now we're starting here at temp and we've copied that to temp3. Then we do temp and we copy A, which is within that, and we've copied that to temp3A and so forth. So here we can see the source and we can see here we've got the destination. Now if there was other things in here, we would also see that too. Now at the moment these are just files, but what we could do is have subdirectories within there. So for instance, I could do a cd into temp and then ls that contents to an ls-f just to make sure that they are just files. Let's do an mkdir and just put in foo and bar as just a single thing here. Let's do a echo and put in this is a test, passing in to foobar and then test. So what we're doing here is we're just redirecting the output, standard output, to the foobar directory, and we're putting it into the test.txt file. So if we did an ls of foobar, we should see the test.txt file. Let's come out of the temp directory here and then let's just do a cp-rv and we're going to copy temp to, we're going to call this temp 4. Let's press enter and now we can see that not only have we copied A, B and C files, but we've also copied the foobar directory and then we've copied the test.txt file as well. So this is a very useful output because it shows you exactly what it is that you're actually doing. Now I mentioned before that we can copy and paste things into different locations. Well, we're currently in the test2 directory. So let's say I want to copy the temp directory into a completely different directory. So let's say I wanted to, I'm going to do an mkdir and we're going to create a directory and we're going to call this my site, for example, my site. So what we're going to do is a cp -rv and then we're going to do temp and we're going to copy that into my site. Press enter here so we can see the temp directory and all of its contents have been copied into the directory my site here. And if we did an ls of my site, we can see that we have temp.
Now, if you found this tutorial useful, do show your appreciation, give it a thumbs up, do share it around. If you've got any comments or questions on this tutorial or any tutorials that I've done, please leave them down in the comments section below. Also, if you've got any suggestions for future tutorials, it doesn't have to be just Linux. I've done tutorials on other bits and pieces as well, including PHP, Docker, and CSS, HTML, JavaScript, and so forth. Put them down in the comments as well, and I'll see what I can do later on in the year. Thanks ever so much for watching. Happy coding, everyone, and I'll speak to you again next time. Cheers. Bye. In this Linux Bash tutorial, we're going to be taking a look at the touch command. Now, this will change the access and modification dates of a file, and it can also create empty files as well. So let's dive straight into the terminal here, and we're in the test2 directory. So if I was just to simply do an ls-l to get the long form output, we can see one of these columns here has a date. Now, this is the modification date of these files, and when we use the touch command, we can adjust these to different times. But before I show you that, I'm just going to show you how to create empty files. This is something that I've shown in previous tutorials, but I just want to recap over it. So to create empty files, you simply type touch, and then you do something like, I'm going to do S, V, and R, and these are going to create new files called S, V, and R. If I was to do an ls-l, we can see that we have V, we have S, and we have R. This was all created today. The next thing I'm going to do is modify the modification dates of those files. You can see that this is when they were modified or when they were created. And there's a number of ways we can do this. If I did info and touch, you can see all the options and all the arguments for the touch command. Touch changes the file access and modification times. That's what it says here. So scroll all the way down here. You can see that there's a whole list of options available to us. Now, I'm not going to go through all of these individually, but we have -a, and the other one was -m. Here we are, changes the modification time of the file. The access time of the file is not changed unless -a flag is also specified. The other option that I'm going to show you is the -r. Now, this is going to reference another file's timestamp. So you can change the current file's timestamp to that of another file's timestamp. There's also a -t. Now, that changes the access modification times to a specified time. Now, you might be using -d in certain distributions, but I'll show you how to do that nonetheless. So to come out of this, as always, press Q or Control-C to quit that, and let's just clear down the screen to make some room. Now, what we've done is we've created all those arbitrary files, the V, R, and S files, and their modification dates were basically the same because we created them in one hit. So if I did an ls-l again, we can see that they're all set to January the 3rd at 12 minutes past 7, which are these up here. Now, let's go and change one of these to be something else. So if we did a touch of -a and m, and we changed, say, V, which is this one down here, what that's going to do is it's going to change that file's modification date to the current date timestamp at the moment. So if I was to press enter here, then do an ls-l, notice that has changed to 7:16, 16 minutes past 7 in the morning. And beforehand, we had that set to 7:12. So that's how you can manipulate a file's modification time without actually changing the file contents itself. You're literally just changing the modification date here. Now, like I said, we can also reference one file to another. So let's say, for example, we want V to be the same as temp4, which was done at 1 minute to 10 on the 2nd of January. So let's do a touch -r because we're going to reference those files. We need to have the source file, which is temp4, and we're going to do V here. So let's press enter and then ls-l,
And what we've done is we've changed the V modification date to be exactly the same as temp4. Now I'm just going to do that again just to recap. I'll just go up a couple of times here. So where we have this as the source, this is also the destination, right? So this is the source, this is what we're trying to reference, and then this is the destination. So temp4 is what we were trying to reference, and V is the file that we wish to change. Before I said that we can not only change the modification date of a file, but we can also change the access date as well. But in this ls-l output, we can only see that we have one date column here, one date and time column, and that is the modification date. So how do we go and see the other bits and pieces about a file? How do we go and see the access date? Well, we're going to use another command. We're going to use a command called stat, which displays the status of a file. Before I do anything like that, though, I'm just going to run info stat just to show you the options that are available here. And if we scroll down, we can see that we have -f, which is the format. We have -q, which suppresses failure messages. And we also have -x, as well as other things as well. X will display information in a more verbose way known to some Linux distributions. We're going to play with that in just a second. Let's press Q or Control-C to come out of here. Let's just clear down the screen. Let's make a bit of room. We're going to be focusing still on the -v file here, or the V file. Let's clear down that. Let's type stat and then V, because we want to get the status of the V file. Press enter here, and we can see that we have a whole gobbledygook of information. Now we can also see that we've got lots of other different timestamps here, and it can be a little bit awkward to work out which one is the access date and which one is the modification date. This is where the -x argument comes in. If we did stat -x and then we did V, or the name of the file that you wish to get some more verbose status from, press enter, and it's now formatted in this sort of more nice output here. So we have the file, which is the file name, the size, which is 0 bytes. We have the mode or the file permissions here. Now, in a previous tutorial, I was talking about file permissions and octal codes. That is the octal code that represents this set of permissions. I'll be talking about that in far more detail, hopefully in future courses. We have the user ID and the group ID here. Again, we're going to be discussing what they all mean later on. And we also have the access and the modification and the change time. Now notice that this was modified to be the 2nd of January 2159. Now that was copied from temp4 directory, but we changed it on the 3rd of January at 22 minutes past 7 in the morning. So we actually have 3 date time outputs here. The first one is when it was accessed, the second one was when it was modified, and the third one was when it was changed. Now, I changed it this morning at 22 minutes past 7, and I changed it to reference the temp4 directory, which had the modification date of 21:59:48. So, just because you've changed the modification date doesn't mean that you've changed the change date. So don't think that you can go into a system and maliciously change all the modification and access dates, because we have a third one here that records when any change was actually made. If you found this tutorial helpful or useful, do show your appreciation, give it a thumbs up, do share it around, and if you've got any comments or questions about this tutorial or any other tutorial that I've done, put them down in the comments section below. I'm also open to suggestions for future tutorials also. Thanks ever so much for watching, happy coding, and I'll see you again in the next one. Cheers, bye. In this Linux tutorial, I'm going to be demonstrating the sort command. Now this command will sort the output or the contents of a file. And we can do that in numeric order and also dictionary order
as well. So let's go straight into the terminal. And what I'm going to do is I'm just going to create a file using standard output redirection, using the redirection of that stream to append a file with a bunch of stuff. So I'm just going to do echo, and we're going to do, let's do 1. And let's append that to a file, which is sort file. Now I haven't created this file yet, sortfile.txt, but it will be created automatically. So press enter here. Let's do another one, but instead of 1, let's do 5. And instead of 5, let's do 3. And perhaps let's do 10 as well, just to have some more bits and pieces. So press echo on that. Now we should have a file called sort file with all of that contents. If we did a cat of sort file, we do. So we have 1, 5, 3, and 10. Let's add another one actually. Let's add another one. Let's say that was 7, just to give it a little bit more randomness. And let's cat that. There we go. So we have 1, 5, 3, 10, and 7. Now this isn't in any sorted order. This is just the raw contents of the file that we've catted out to the screen. But we can sort this. We can order this output in numeric order. So what we can do is sort -n, and then we can type the sortfile.txt, what it is that we wish to sort. Press enter here, and we have 1, 3, 5, 7, and 10. So that's sorted that in numeric order, and that is what the -n option does. We can also reverse this order if we wish, so we could do sort -n and then R, or -R and N, or -N and -R, doesn't matter, and then sortfile.txt, press enter, and we have that now in reverse order, so 10, 7, 5, 3, and 1. What happens, however, if there are two numbers that are exactly the same? Let's just echo out, let's put in the number 10 again, and put that into the sortfile.txt, press enter here, and let's just cat that out to ensure that we have that. So we have two 10s, 1, 5, 3, 10, 7, and 10. Now obviously if we did a sort of -n of the sort file, then we have 1, 3, 5, 7, and 10 and 10. We might, however, want to keep this nice and unique and remove duplicates. Well, we can do that by using the -u option. So we can do sort -n and then u, and also pass in what it is that we wish to sort. Press enter here, and what we've done is we've removed the duplicate. So we've removed the second 10 here. Now I mentioned before that this can also work with dictionary words as well. So what I'm going to do is just do a echo, and we're going to pass in A, and we're going to append that to the sort file, and we're going to also do Z as well, and we're going to do let's do F. And let's just cat out the sort file. So we have 1, 5, 3, 10, 7, 10, A, Z, and F. Now, by default, it will sort by dictionary order. So if I type sort and then sort file, press enter here, it will go A, F, and Z. So beforehand it was A, Z, and F. Now it's A, F, and Z. And also what we've done is we've sorted these numbers too, because that's 1, that's 10, that's 10, that's 3, 5, and 7. If I was just to simply cat this out, so cat of sort file, we can see that it's originally is 1, 5, 3, 7, 10, and 10. So sorting dictionary words will also manipulate the numbers too. Now to get the information of the sort command, type info and sort, and here we can see the usage information of the sort command. So sort lines of text files. Scroll down here, and what we did is we used the R, which was the reverse result comparison, the N, which was the numeric sort, and we also by default used a dictionary order. So that was -D. Now, there's other things here that we can do, and I won't be focusing on that in this tutorial, but we can do all sorts of things with the stability, the buffer size, and so forth. We also used U, which was to sort it and return only unique results. And you can also see that there's all sorts of different options and arguments available here. To come out of this, just press Q or Control C. Now, if you found this Linux tutorial helpful or useful, then do show your appreciation, give it a thumbs up. Put your thoughts or questions down in the comment section below. Also, let me know if you've got suggestions for different courses and tutorials that you would like me to do. Thanks ever so much for watching, everyone. Happy coding, and I will speak to you again in the next tutorial. Cheers. Bye. In this Linux tutorial, I'll be demonstrating how to use the du command. That shows the disk usage. So let's just dive straight into the tutorial here. Let's go into the terminal. And if I did an ls-l of this current working directory, as we can see, it's quite large now. We can see all of the contents, and here on the in this column we have the bytes. So these are the bytes of file size that were taken up by each one of these pieces of content. These here are directories, and this is the amount of bytes that the whole contents of that directory takes up. So that's 204, this is 170, that's 204, and so forth. But we can actually find out more information about this, and we can also do it in perhaps more of a human readable form. What I'm going to do first of all is just type info and then du for disk usage. Press enter and we can see the usage of du. Scroll down here and you can see all sorts of lovely options that we can play with. We're going to be focusing on the -h, the lowercase h here, the human readable output. That will suffix byte, kilobyte, megabyte, gigabyte, terabyte, and petabyte if needed. So it actually gives us some human readable output. We're also going to play with -a because that's going to display an entry for each file in the hierarchy and other bits and pieces as well. But look, there's all sorts of things that we can do, especially with symlinks and blocks and stuff like that. Bits and pieces that we haven't even talked about in this course so far. So I'm not going to focus on that in this lesson. So let's press Control C or Q to come out of here, and let's first of all just do a du without any options at all and just see the raw output of this command. Press enter and we can see that we have all of the folders here. So we have my site, temp, foobar, my site, temp, my site, and then all these temp folders here. And we can see that we have this file size. Now, what does this file size mean? Because it's just a number. This is where the -h comes into play. So let's do a du -h and press enter, and we can now see that that has gone up to 4 kilobytes, and here we have 52 kilobytes. So this is kind of a rounded up amount of size that these pieces of content take up. And here we've got a single dot, which means the current working directory contains 52 kilobytes. Okay, let's do a du-a and also a h. So let's press enter here, and now what we've done is we've gone through every single piece of content, including all the files, all the directories, even if they have 0 bytes, and we've displayed their output here on the left hand side. So if I scroll up a little bit here, we can see all the files that we've got. So we've got the hidden file, which is 4 kilobytes, and then we've got all of these empty files. We also have the My Sites again, and then we've got some more empty files and so forth. Notice that they all start with a period. This means that you're in the current working directory, something that I've mentioned before in a previous tutorial. Also, something to note is the du-h command, or just the du command, doesn't actually display the hidden file. So if I scroll up to again here, we can see that we have the hidden file here because we've used the -a, which gets hold of everything. Now the du command is extremely useful because it displays the usage, the file usage, the disk usage of the contents of your directory. So for instance, if you have an issue with file size, then use the du-h or even the du-ha to display all of the contents in this output. Now, this output isn't ordered at all, and it's actually ordered by the contents rather than the file size. We're going to be looking at how we can advance the du command in future courses, perhaps. If you found this tutorial helpful or useful, then do show your appreciation, give it a thumbs up, do share it around to those that might find it useful as well. If you've got any comments or questions, put your thoughts down in the comments section below, as well as if you've got any suggestions for future tutorials that I can do. Thanks ever so much for watching, guys. Happy coding, everyone, and I will see you again in the next tutorial. Cheers. Bye.